Right. Hi, everyone. I'm Soonbong from Yale School of Management. Today, I'm very excited to give you a summary of our paper, Dynamic Matching with Post-Allocation Service and its application to refugee resettlement. This is a joint work with my co-authors Kirk, Vahideh, and Elisabeth. Refugee crisis is a pressing global challenge with more than 35 million refugees around the world as of 2023. Refugee resettlement is a durable solution to help these vulnerable populations by relocating them to host countries and helping them find a new home and also new job in the new communities. However, the decision making in this resettlement program is very high-stake decisions. Particular, the initial placement of refugee family within a host country has a significant impact on their employment outcome. Now, given this importance of this placement decision making, there is also significant opportunity to improve operations by using data-driven algorithmic assignment framework where we can predict the pairwise employment outcomes between refugees and locations using machine learning model. And we can use these predictions to optimize placement decision making. Now, focusing on this latter effort of optimization algorithm, we have collaborated with a major US resettlement agency to design the placement algorithm by incorporating novel operational considerations. Now, to understand what kind of novel operational considerations that arise in this context, let me first describe how this resettlement process can be naturally modeled as a dynamic matching problem. So in the US, the resettlement horizon is usually one fiscal year, and refugees arrive sequentially, usually week by week. So whenever the refugee arrives, the resettlement agency must immediately match this refugee to one of the location affiliates without knowing future. Now, before they make a match decisions, our partner agency has already built an in-house machine learning model that can reasonably predict the pairwise employment probabilities, and they can use these probabilities to make a match decision. Given this ingredient, then our natural goal is to maximize the total employment outcome subject to our partner's own resource limitation. In particular, each location affiliate has their own annual quota or capacity on the total number of refugees they can resettle in a given year, and we want to respect this as much as possible. Furthermore, what's novel in this context is that locations also provide post-allocation service. In particular, when the refugee arrives at the matched location affiliate, they often require onboarding services from local service providers like job search assistant. Because we have a limited number of service providers, it's very important to avoid congestion of this post-allocation service. Furthermore, let me remind you that refugees arrive sequentially, and therefore we still have a fundamental challenge of not knowing futures when we make a match decision for this particular refugee at this week. Now, to deal with this future uncertainty, existing proposals in the literature of refugee matching has relied on data of past years to simulate future arrivals. This is a reasonable approach, but in our context, we also found that it can be non-robust because there is significant year-to-year fluctuation of the refugee pool composition. As an illustration, in the United States, there's a special type of refugees called tied cases who must be matched to a predetermined target affiliate because they already have a family at that location. When you look at the data, we found that this number of tied cases significantly change across different years. And this means that we need to take a distribution-free design approach by not relying on potentially misspecified past year's data to predict the arrival patterns. Okay. So given these ingredients, our goal was to design a dynamic matching algorithm that can optimize for the employment outcome, but also incorporating specific operational considerations. Particularly, we want to respect the annual quota as much as possible, avoid congestion for post-allocation service, and fundamentally, we do not want to require distributional knowledge which comes from past year's data. Okay. To study this question, we first built a fairly general novel framework of dynamic matching with post-allocation service. And our model captured these two salient features. First, refugees arrive dynamically, but their arrival pattern or distribution is not known to us. So we need to learn them dynamically. Furthermore, each placement of refugees at location utilizes two types of resources. The first one is a static resource, which is modeling the annual quota. And the second one is dynamic resource, which is essentially the server that provides post-allocation service. And we model this post-allocation service as another queuing process at each location. Okay. Now, within this framework, we design a dual learning algorithm. The high-level idea of our theoretical development is to learn the underlying dual variables of this optimization problem as we make the decision along the way. And we use these estimated dual variables to design a simple score-based matching algorithm. In the paper, we prove that our algorithm achieves a near optimal performance guarantee. And further, when we test our algorithm on real data from our partner agency, we find that our algorithm significantly improves performance both of the current practice and state-of-the-art existing proposals that relies on the data of past years to predict arrival patterns. Okay. So with this, we believe that our paper shows a good use case of operations research to improve high-stake decisions affecting vulnerable populations, which is also often made in the face of many operational intricacies. But beyond this application of refugee resettlement, our framework can be also useful to other applications where post-allocation service naturally arises, like healthcare or adult foster care system. So with that, let me conclude. Please feel free to check our full paper if you want to know more details. Thank you.